Hello, grade 11. So this is a video just for you to know how can we represent the forces that are acting on a particle or on a system that is moving on an inclined plane. Okay? What do you mean by inclined plane? Inclined plane يعني منحنى that is making a theta or an angle theta with the horizontal. This is the horizontal line as you can see. Okay? So here it's given that a block is sliding on an inclined frictionless plane. Find A, or the acceleration of the block. This is block of mass m, okay? It's sliding on a frictionless plane and it's sliding, it's going in this direction, okay? And along this surface in this direction. It's sliding and it's going in this direction and along this line. Okay, on a frictionless surface, it means that this surface exerts no friction. There's no friction force that is opposing this block. Okay, now to find A, first we have to represent the forces that are acting on the surface, and we have to know the forces that are acting on the block. So we have to use Newton's second law, right? Which tells us that F, the external forces, okay, the sum of the external forces that are acting on the system, it's equal to times the mass of the block or the system times its acceleration. Okay, so we have to use this formula, Newton's second law. Okay, let's first step we have to represent the forces on this diagram that are acting on the system or on the block. What are the forces that are acting on the block? First, it's the weight of the particle, right? The weight which pulls the particle vertically downward. It always pulls it downward. Its weight pulls the object downward. Okay, so this is the vector, the weight vector, or the gravitational force. It's the same thing, يعني. Fg. Okay, and we represent it by a vector which is vertically directed downward. Okay, this is the weight vector. Now the other force that is acting on the system, it's the normal force, of course. Why? Because the normal force, it's the force exerted by this surface. So the block is placed on this surface, right? And this surface exerts any surface exerts a normal force which is perpendicular. As you can see in this vector here, it's perpendicular to this surface, right? Always the normal force is always perpendicular to the surface. So this is the normal force. Okay, these are the only two forces that are acting on the system because there's no friction and there's no other force that is acting on the system other than these two. Okay, so we can, on the left side here, what do we have? What are the forces that we have that are acting on the block? We have normal force, normal, and plus what? The Fg, which is the weight. Got it? These are the two forces that we have. And we just can, on the other side, on the right side, we can copy what is written above times A. Okay? Now, the next step, what should we do here? We should remove our next step. We should remove the vectors, and we should, instead of the vectors, we should write down the components of each force, okay? The components of each force. To do this, we have to choose a coordinate system, okay? So let's take when you have this case, when you have the cases where you have an inclined surface, the direction of motion, this block is sliding along this axis. This axis we take as you can see, look at the surface here, the inclined surface, we take it to be the x-axis, the positive x-axis, okay? Positive x, and here, and this axis here, we take it as the y-axis. Do you see it? If we can extend this line, and this is the positive y-axis, okay? So we chose this axis to be the x-axis, okay? And this axis is for the y-axis, okay? And this block here is moving along what? Is moving along, it's sliding along the positive or towards the positive x-axis, okay? In this direction. It's sliding in this direction. So it's accelerating along this line, okay? Okay. Now, if we want to now put the components of each force or each vector, let's take a look at the normal force. The normal force, it has only one component, which is along the y direction, right? Its component is only along the y direction. It has no component along x. And what is the sign of this component? It is positive. Why? Because it is along the positive y direction, right? So we can remove the vector and put the component, which is n positive ny, because it is directed in the positive y direction. Okay? Positive ny. Now, Fg, let's take a look at the weight or the gravitational force acting on this block. We can look at Fg and see that and notice that it does not have only one component. It's situated in the xy plane, as you can see. So it has two components. Yes, it has one in the x direction and one in the y. How can we get these two components? We project to get the x component of this vector, we project this vector on the x-axis, and you will get fgx, which is this one, just this part here. Did you see it? Okay, this is fgx, and it's pointing in this direction, and this positive x direction, fgx. And if I want, this is, as you can see, this is fgy. Okay, how did we find it? You project fg on the y-axis, and you will find that this part here it's the fgy, which is equal, which is the same as this part, which is also fgy. So we consider this part to be fgy. Did you see it? Okay. So now fg has two components, one in the x and one in the y. Did you see it? Okay, now we want to find the angle inside this triangle. Did you see the triangle, this small triangle? We need to find the angle theta. What should we do? To find it, we need to compare this small triangle, as you see, with the big one, which is, if we extend the FG, the force, the weight force. Let me extend it and show you. Okay. Okay, I extended the FG, okay, to meet with this axis at the bottom. Look at the big triangle, which is this one. Can you see it? This angle here is 90 because this line is perpendicular to this axis, and this is theta. Okay, here we have this angle, if you can see it. It's common between the big triangle and the small triangle, right? This is the small triangle, okay? Did you see it? And this is the big triangle. Big triangle, okay? So now how can we find angle theta? If this angle is common between the two triangles, the big triangle and the small triangle, and this here, it is the perpendicular because if you remember, we projected the FG. This is FG. We projected it on the x-axis, so this angle it's 90. So this angle here, it's theta. Okay, if you compare these two triangles, you'll find that this angle, it's theta. Okay, got it? I hope this was clear enough. Okay, so now if I want okay, let me now write the components of this vector first, and then we will use the cosine rule and the sine rule. Now, look, FG, if I want to write the components of FG, it's FGX and FGY, right? Let's look, FGX, it's in this direction, so it's in the positive X direction, right? Plus FGX, right? And FGY, as you can see, it's along this direction. This is FGY. This is FGY. Okay? So it's pointing in the negative y direction. This is the positive y direction. This is the negative y. So this is minus FGY. Minus FGY equal to M times A. Okay, now here we removed all vectors and we just wrote down the components of these vectors, okay? Okay, let me just... Okay. This is here, as we said, this is FG. Okay. This here, it's FGY pointing downward. And this vector here, it's FGX, okay? And this angle is theta. هيدي الانجل هي theta, as we said. How can we find theta? Now to find FGX and FGY, we use the cosine theta and sine theta rule. I explained it in a previous video. Cosine theta, it's adjacent over hypotenuse. The adjacent side to angle theta, if you look at this triangle here, the small triangle, if this is the 90-degree angle, okay, as we said, this is 90. The side facing 90, this is the hypotenuse, which is FG, right? This is the factor FG. This is the weight vector, right? Okay. So cosine theta is the adjacent side to angle theta, which is FGY, as you can see. This is the side which is next to angle theta. Okay, this side. Did you see it? FGY. So FGY over the hypotenuse, which is FG, okay, which is the hypotenuse is the side facing the 90 degree angle, so it's FG. So, okay, and sine theta, what is the rule for sine theta? Sine theta is opposite. You can check my video on the components, okay, of the vector. Sine theta is opposite over hypotenuse. The opposite side to angle theta. What is the opposite? Yani side that is facing the angle theta. It's this side, right? This is the side that is facing the angle theta, which is FGX. FGX over the hypotenuse, which is the same FG, okay? So now if I want to find FGX and FGY from this formula, FGX is what? It's FG, just cross multiplication, do cross multiplication, okay? FG times sine theta, okay? FG sine theta same thing for FGY. FGY, it's equal to FG cosine theta. Okay. So now we can substitute these values in the equation here. Ny. Okay. Plus FGX. What is FGX? It's FG times cosine theta, right? Okay, but FG in the force, the weight, what is the formula for the weight? It's mg, right? So instead of FG, I can write m times g, right? mg cos, no, this is, I'm sorry, this is FGY. So it's mg sine theta, okay? If you want to substitute FGX, it's mg sine theta, yes? Okay, mg sine theta plus mg plus mg cosine theta equals to ma. Okay, and this here minus. This is minus, not plus. Okay, now what? Look, this block is sliding along this direction, along the x-axis, right? It's moving along the x-axis. Okay, it's at rest along the y, and it's not moving along the y direction. So the net force along the net force, the forces, the external forces that are along the y direction, the sum of these forces are equals to zero, are equal to zero. Why? Because there's no acceleration along the y. So the sum of these forces are equal to zero, right? So we can cancel the forces that are along the y direction. Because why? Because the block is not it's at rest along the y direction. It's not changing its speed, okay, in any way, okay. So we can cancel the normal force because it's along the y direction and the block is moving along the x direction. And we can also cancel, what else? We have the FGY, which is along the y direction. So we can cancel it too, okay? We will end up just with the force that is directed along the x-axis, and that force is FGX, which is mg sine theta. Okay, so mg sine theta equals to ma. If I want to find now here in this example, I did not get I did not put any value. I just want you to know how we represent the forces and how we can solve such a problem. Okay, to find A, what can you do? A is equal to mg sine theta over m. Okay, mass will cancel out with the mass in the denominator, and we are left with A equal to g sine theta. G times sine theta. Okay, if you have values, of course, for G you can, it's 10, okay, it's 10 meter per second squared. And theta, it depends on the problem, okay, but here we don't have values, so we can stop here. I hope this video was helpful. Thank you for watching.